Earth's water supply is divided into two main types: salt water and fresh water. Humans, plants, and animals rely on fresh water for survival. Although water covers much of the planet, about 97% of it is salt. Because salt contains high levels of salt and other minerals, it is unsafe for living things to drink. In general, salt water is found in Earth's oceans. Oceans are vast bodies of water covering 71% of the planet's surface. There are 5 main oceans: the Atlantic, the Pacific, the Indian, the Arctic, and Southern, with the Pacific being the largest. Let's listen to a song. It's by Hopscotch to help us memorize all of the oceans.
About 70% of the surface of the earth is ocean water, and it's divided up in 5 parts from biggest to smallest: Pacific, Atlantic, Indian, Southern, Arctic. Pacific, Atlantic, Indian, Southern, Arctic.
I'm the Pacific, to be specific. I'm a third of the Earth's surface where my turf is, and my Mariana Trench is the very, very deepest in the sea.
And I'm the Atlantic, named after the Greek god Atlas, with the Bermuda Triangle and the Gulf Stream in me.
I'm the Indian Ocean, I'm the warmest around.
And I'm the Southern Ocean, where Antarctica is found.
And I'm the Arctic, the smallest and the shallowest, but that's fine, you see. I've got more ice than you've ever seen. Even polar bears walk on me. We're the Pacific, Atlantic, Indian, Southern, Arctic. Pacific, Atlantic, Indian, Southern, Arctic.
One more time.
Pacific, Atlantic, Indian, Southern, Arctic. Pacific, Atlantic, Indian, Southern, Arctic.
Okay, let's. So our water supplies, or water on our Earth, is broken down into salt water and then fresh water. Fresh water is about 3%. It makes up about 3% on the Earth. Fresh water just means without salt. And our total water supply is just that 3%. So what we drink and what we use comes from just that 3%. Most of the water is locked up in what scientists believe are in glaciers. So most of our fresh water is locked in glaciers. And those are in the Arctic regions and the Antarctic regions. But of course, polar bears are very thankful for that, because there is much wildlife that relies on that frozen glacial area to live and hunt. So most of the fresh water you use every day is found in lakes and rivers. This is called surface waters. It may seem like we have a lot, but it is actually less than 1% of our water supply. Precipitation is the third part of freshwater. So we've got glaciers, surface water, and now is the precipitation. Precipitation, another name for it: rain, snow, sleet, hail. It all gets collected in the streams or rivers that flow towards the oceans. So precipitation can come in many different formats, but it all goes to the ocean. Water found below Earth's surface is groundwater, and that's the fourth of that we're going to be looking at under freshwater. In some places on Earth, groundwater actually bubbles up right from the ground. So this picture shows an actual stream, but it has groundwater or something called a spring, a natural spring that bubbles up, and it bubbles up fresh water. More often, however, people get their groundwater, they have to dig holes. They can do that by machine or by hand to reach the fresh water, but it all entails digging down to be able to reach that well. Okay, so let's now review some of the freshwater components because we've looked at all the fresh water. I want to flip over to a video by NASA that explains a little bit more in detail so you have a different medium for learning about the different types of fresh water.
As humans, we're well aware we need water to live. Fortunately for us, we live on a water planet. But that doesn't mean we have an entire globe of H2O to use as we please. So just how does the usable water break down for us? A giant 97% of Earth's water is in the ocean, so we can't use that. 3% is fresh water, but even in that small sliver, about 2% is locked in glaciers, ice caps, and groundwater. That leaves about 1% of the fresh water on Earth that is accessible and usable by humans. Let's imagine all of that accessible fresh water fits into this tiny pool. Now we'll get to some small numbers when we look at global freshwater. There really is a small fraction of usable and accessible freshwater on this water planet, so how do we use that tiny pool? In the United States, about 49% is used in thermoelectric power production, while agricultural irrigation makes up about 31%. 11% goes to public use in our cities and towns, 4% goes into industry and manufacturing, and 1% is domestic use. The water coming out of our faucets largely comes from precipitation. Measuring how much or how little precipitation falls can impact how we live our daily lives. Elsewhere around the globe, in developing countries, agricultural irrigation accounts for about 70% of freshwater use, while industrial use is 20% and 10% for public consumption. In places where access to usable freshwater is greatly limited, knowing when and where precipitation may fall is critical to livelihoods. Precipitation replenishes these tiny reservoirs of fresh water, and data from the Global Precipitation Measurement Mission will help farmers, ranchers, and policymakers in these regions plan for periods of drought, flooding, and other extreme weather.
So water also occurs in the air. Oops, we went through this already. Let me flip through. Sorry, it repeated. So as we're looking at the water and where it comes from, the fresh water, it can also be found in invisible gas in the air. Water vapor. Water is always moving. As water heats up and cools down, it moves from the planet's surface to the atmosphere or sky. This is probably the most important process in nature to us. It's the water cycle. So I wanted to go through, because it's such an important process, I wanted to go through also a video on this too. Unfortunately, I didn't boot it up beforehand, so you'll have to bear with me as I copy and paste. Make Make sure I have it. Hopefully it doesn't take too long to load. It didn't copy. Okay, hang on. Oh, there we go. That makes it easier, just clicking on it. All right, so this is a video about the water cycle.
The water cycle takes the water and moves it up and down and all around the earth. The water cycle takes the water and moves it up and down and all around the earth. The water cycle takes the water and moves it up and down and all around the earth. The water cycle takes the water and moves it up and down and all around the earth.
Evaporation comes when the heat from the sun warms up all the groundwater, then it turns to water vapor. Condensation takes over, it goes up to the clouds. Water vapor cools down and it changes to a liquid now. Precipitation happens when the drops get big. It falls like rain, snow, sleet, and hail upon my head. I know it's the water cycle happening again. Evaporation, condensation, precipitation.
The water cycle takes the water and moves it up and down and all around the earth. The water cycle takes the water and moves it up and down and all around the earth.
Evaporation comes when the heat from the sun warms up all the groundwater, then it turns to water vapor. Condensation takes over, it goes up to the clouds. Water vapor cools down and it changes to a liquid now. Precipitation happens when the drops get big. It falls like rain, snow, sleet, and hail upon my head. I know it's the water cycle happening again. Evaporation, condensation, precipitation.
The water cycle takes the water and moves it up and down and all around the earth. The water cycle takes the water and moves it up and down and all around the earth. Evaporation comes when the heat from the sun warms up all the groundwater, then it turns to water vapor. Condensation takes over, it goes up to the clouds. Water vapor cools down and it changes to a liquid now. Precipitation happens when the drops get big. It falls like rain, snow, sleet, and hail upon my head. I know. It's the water cycle happening again. Evaporation, condensation, precipitation. The water cycle takes the water and moves it up and down and all around the earth. The water cycle takes the water and moves it up and down and all around the earth. The water cycle takes the water and moves it up and down and all around the earth. The water.
All right, we're back. So hopefully that repetitive song got it in your head, the water cycle, the terminology, how it works, because that is going to be on the quiz. So this lesson had a lot of information in it, but some of it was review from previous lessons, and there was a couple things that were new too. So make sure that if you don't understand something, or if something is not working in your brain, keeping those concepts in, that you can go back and look at the video and the lesson. You will need to know the difference between salt water and fresh water, the names and info of the 5 main oceans on our planet. Remember, we went through and named the 5 and the song that was with that. So you need to know the 5 main oceans of our planet, what makes up fresh water, Remember, we went through the glaciers, the surface water, precipitation. You listen to that song for that, and the groundwater, the difference between all those that make up fresh water. And of course, have an understanding of the water cycle, because that is a very important thing. The water cycle you'll be using for quite a few years, so it's something that you'll want to learn. So now it's time for you to flip over back to the agenda, click on the lesson quiz link, and good luck.